Hey guys, what's going on? Welcome back to the Your Forest podcast. I'm Matthew Christoph. Today's podcast is brought to you by Greenlink Forestry, providing high quality resource analysis for over 15 years. And it's also brought to you by Damaged Timber. Damaged Timber is a Canadian-based outdoor apparel brand that supports conservation and awareness of public lands. They through the sale of all their shirts and stuff, they're taking 10% off, and they're going to create a scholarship for people going into natural resource based management or natural resource based programs, I guess. And yeah, they have really awesome stuff. They're right out of Edmonton here. They have really nice T-shirts, really nice hats, really nice toques, and they're looking to expand their menu all the time. So yeah, definitely check them out at damagedtimber.com. If you buy anything from there, at checkout, if you put in Your Forest 10, you'll get 10% off all additional sales that are already there. And also, I think next Friday, so Friday, the Black Friday, whatever day that is November 24th. They're having a Black Friday sale. So check that out. I'm not sure what the details are, if he's how much they're having off, but you'll get 10% off of what's already on there. So good deals. Check them out. It's gonna be good. And so yeah, today I've got a researcher on today. Actually, his name is Francois-Nicolas Robinne, and he is a PhD candidate in forest biology and management for Canadian Partnership for Wildlife, Fire, and Science. He is out of Edmonton here. And yeah, I know we've been talking lots about fire. I've had 2 podcasts on fire already, and I mentioned it a lot. But this one is more. It's water. It's about the relationship between wildfire and how that affects water and the water we drink and bathe in and all that kind of stuff. And water's it's a basic human right. We all need it. And with the current climate and environmental changes that are happening, we're seeing an increased risk of fire. And so the increased risk of fire has an increased risk on our water, more pollutants, more sediment, all that kind of stuff. So we get into how wildfire and drinking water are related and kind of the risk involved there. And yeah, it was a really interesting podcast. I really enjoyed it. I hope you guys like it. Yeah, so check it out. This is Francois and I. Yeah, it's as simple as me hitting a button and us doing a podcast.
All right, and so they let you. So your company is like on board with that as well.
Totally, yeah.
Oh, that's great.
No, Derek's
that's
been
awesome.
great with it. Well, I first kind of came up with the idea. I listen sometimes here when I'm like delineating and stuff like that.
Mm-hmm.
It's mostly just tracing lines, right?
Yeah.
So after you know what you're doing, I kind of need something else to keep me going. So I'll listen to music long enough, and then you're okay. Well, I'll start to listen to a podcast or whatever. So I start listening to podcasts heavily. And then I could never find one that was like environmental based.
Yeah.
And I was like, yeah, I could definitely do this. Why not? Just kind of an epiphany moment, right? And I'm like,
Yeah.
I'll give it a try. Like worst case scenario, it like takes up some of my time and I learn some stuff. So yeah.
Well, that's awesome, especially when your company is like supporting you on that.
Oh, big time.
That's
yeah.
good.
Yeah. No, he gave me the space and like hooked me up with some art for the walls so it doesn't look like a closet.
No,
and,
that's
like,
awesome. That's pretty awesome.
tables, chairs, and yeah, all this good stuff. So no, it's been good. Yeah, he's been really supportive.
Wow.
Yeah. So no, I've been enjoying it, man. It's been awesome.
I bet.
Yeah. So anyways, thanks a lot for coming on. This is gonna be great.
Yeah, I'm sure about that.
Yeah, I think like you were saying before we started here is like people have a hard time understanding the relationship between like wildfire and water, I guess, right? And like well, fire puts out water, like how does that or whatever, right? So yeah, I guess like where I kind of wanted to start was I think I sent you the questions there, but just I think we need to explain the climate change portion of it and how there's increased fire risk and severity's going up and all that. So if you could maybe just start there.
Well, yeah, sure. So so climate change, obviously, people hear that all the time, every day.
Yeah.
And I guess when it comes to the problem at stake here, like in our discussion, I think we have to put that in perspective of I prefer to talk about global environmental change, and in which climate change is, I would say, only a part. It's a big part of global environmental change, but there are many other things to consider, and especially when it comes to wildfire issues. Like, let's not talk about water for now. Just let's talk about fire.
Yeah.
So yeah, like climate change will bring more fire-conducive weather. So what we will have during the course of a year, for instance, in Canada, we will have, and we already see that, like longer fire season. Like since the 70s, it's like our fire season here in Alberta has got longer by more than 1 month.
Yeah.
So it's something to consider, sort of fire conducive weather. We have that more during the year. We also have weather that will be more conducive to lightnings, just so because you have more heat in the atmosphere, it usually just creates more, like convective systems, and so you have more thunderstorms.
So actually more storms.
Exactly.
Oh,
and
crazy.
so you have more lightnings, and lightnings are especially in the northern boreal forest are very, like, the most important vector of wildfires.
Is it the most? Does it start the most fires?
So there is a huge global variability. We know that at the global scale, it's mostly human-caused fires.
Global scale,
and there is this historian down in the U.S., Stephen Pine, who said, like, now the global scale, natural fires have become outliers.
Oh, really?
But then and once again, there is a whole lot of variability in that, and I think, like, I will come to this word a whole lot during our conversation. But in the boreal forest, it really depends. In the boreal forest, I would say, depending on where you are, could be like 1/3, 2/3, 1/3 lightning, 2/3 human. And if you really are in the remote areas, that would be mostly lightning caused fires.
Yeah. Okay. Yes. That's just something I was thinking of, because I think most of the fires that I've actioned as, like, I was a Helitac member for a few years, and as far as I could tell, most of them were lightning caused, right? But they're, like you said, they're in remote areas. They're not.
Yes.
So if you consider anything started from a campfire that's in a provincial park or something, that's not actioned that way. So it's I guess.
It always depends how, like, if you do, like, even provincial scale statistics, then you will see, just that might be, I'm not sure anymore about the number, but that might be like 45% lightning and 65% human. I'm not sure, might be the opposite. But anyways, it gets closer when you work at a larger scale. Yeah. And when you start to actually, if you only want to focus on the natural part of the boreal forest, you will see that it's mostly lightning fires.
Right.
So
and those are the ones that are detected too, right? So there's a lot that they start, and whatever rain comes with the lightning gets pounds it out, and it's
that's where lightning, like naturally caused fires, are the most difficult to first to predict, but also like to see coming, because you can have, like, the worst thing would be like dry thunderstorm, so you don't have rain. That would be the worst. But even sometimes it could rain, but you will have you have a lightning hitting a tree, and all this energy, this heat, will go down to the root system of the tree. And let's imagine this, despite the rain, like the soil is fairly dry, like, let's say at the spring or whenever during the fire season, the soil could be pretty dry despite the rain. And so you will have this like an ignition down in the ground, and this ignition, like, will just smolder. Like you don't have enough oxygen for a flaming fire, but you have still enough heat and like organic material to just burn the ground. And then it can keep going for days, weeks, even months, and at some point you have start to have wind on the surface, and it will just cut up and up, and it goes. So and so that's why it's very difficult to predict. It's very difficult to see coming, and also because it happens in the middle of nowhere. So like for the time for someone to actually see the start of a smoke and things like that, like quite often it has already.
It's already gone. It's already taken off. So then, talking about the climate change or environmental change aspect of it. So generally speaking, global temperatures are increasing. So that's creating more situations where there's drier temperatures, longer fire seasons, so more opportunity for fire to happen.
Yes, exactly.
You're getting more updrafts. You're getting more actual thunderstorms. So again, increased probability. And then, like, what about things like, for example, the pine beetle epidemic that happened?
Well, that's a good question. So it's
is that environmental related? Like, is that
climate
change related?
Well, we know that for instance, like the southern like the northern limit of, for instance, mountain pine beetle,
Yep.
as you know, is higher now in latitude than it used to be a few decades ago. You know,
Right.
so it's like we see the effect on like pathogens,
Yeah.
like the effect of climate change of pathogens. So, but as far as I know, and it's not my specialty,
Right.
but as far as I know, there are not so far clear relationship between forests that have been decimated by mountain pine beetle or other pathogens and fire occurrence or area burn. So like
Gotcha.
other specialists may say make more like firm statements, but as far as I know, and a few things I've
It's not your specialty.
it's like there is no clear. It's still an active. I know it is still an active field of research, because so far there is no clear response to that clear answer. So, but the thing is, like, and climate change, when it comes to fire, it's only one part of it, and that's why once again I want to talk about. I prefer to talk about global environmental change, because to have a fire, you need ignition. So lightning ignition when it's natural cause, but we know that now, and especially at the global scale, it's mostly human caused ignitions. So and whatever the climate, you have people in the landscape, and more people in the landscape in many places of the world. And look, in Canada, the boreal forest is still under active development, and the government has plans to keep developing the north. So we will have more people in the landscape, and I think that's really something to think about. And the Fort McMurray fire is a very good example of that. Just like when it happened, like the media, and even in the social media as well, but the media jumped on, oh, it's climate change, and it's like, well, it's very hard to make this connection. Even if there are some signs, like it's very hard to make this connection for one single event. And it's also, you have to point at people the fact that, first of all, like 2011, the Richardson fire was bigger than the Fort McMurray fire, but it burned up in the boreal forest where there is nowhere. So, just people are like, they don't really have that in mind.
It's easy to make the correlation, but correlation doesn't always equal causation.
Exactly.
Right? Classic.
And plus, the Fort McMurray fire, like the probability for it, like it was a clear sunny day. It was not started by a lightning, so it's not a naturally probably not a naturally caused
I'm sure
fire.
if it was caused by a human, like on purpose or something like that, we'll never know, because that's
we'll never know. When us scientists, we have to be careful as well when we talk about that, because as you said, there is no 100%. We are not sure 100%, but like it's probably human caused fire. So just like then when people jump on climate change, just like try to think of like the bigger picture, and like the fact that people are in the landscape, they are the major cause of. Like a major cause of ignitions. And look at what happened in BC this year. Many fires we know were human caused. So it's something. It's really something to keep in mind before jumping at climate change in the cause of the disasters we see. It's like to have a disaster, you need an extreme natural hazard, but you also need values at risk. Because as I said with the Richardson fire, we had a huge fire, but no values at risk whatsoever. And probably it made some good to the boreal forest as well, which is a fire-dependent ecosystem. So, but then as I said, to have a disaster, you need this extreme natural hazard, but then you need those values at risk. That could be ecosystems, that could be obviously like people and goods, like your house, and that could also be like water in my case. But it's really something to keep in mind, not only with fire, like the floods in Houston, for instance, this year. So yes, this year is a very particular year for the occurrence of hurricanes, and whether or not they are linked to climate change. Even the IPCC is reluctant to make a clear statement on that. So that might just be an exceptional year, maybe. But the fact is, then when among all the articles I read about that, only a few started to say, but we have to also look at the urban sprawl in the Houston area,
Okay.
and the fact that this urban sprawl caused they basically covered the whole what they call bayous, so
Yeah.
like this system of wetlands
Yeah.
that
Just people intermingled throughout all the wetlands.
yeah, and
so,
you know,
yeah.
and the thing is, like, you lose, like, we know that wetlands act as like natural buffers, like, you know, like sponges, and
Yep.
like, they just suck up all the water.
Mm-hmm.
So I'm not saying that if they had not built on those areas, like, you wouldn't have flooding, but maybe it would have been less.
Possibly,
Yeah.
yeah.
So, and hopefully we'll know at some point. Some people will, you know, like go and do the exercise of comparing whether or not the result would have been different. But what I mean is, like, we really have, I think we tend to not consider enough, like, the impact of what we do in the landscape. And when it comes to fire, like in California just a few weeks ago, like like the state was devastated by fires. But it's a fire-prone environment in which we put more and more people, and people who are not in many cases. Yeah, it's dangerous, but also many people are not aware of that. And we also have this issue. I come from France, where in southern France it burns quite often as well, and it's quite common to hear people saying, like, yeah, but, you know, just fire is an enemy. Like, we don't want fire in the landscape. We don't accept that. Despite the fact, you say, yeah, but fire was here before you, and like the ecosystem you value so much. You know, some people are like, yeah, I installed my house and I want to be able to look at this beautiful landscape. And you say, yeah, but this beautiful landscape is fire dependent. So if you don't keep fire in it, you won't keep it.
Well, yeah, it's even if you don't allow it to burn, it's gonna burn regardless of whether you want it to or not. Like, you see all these beautiful cabins in the mountains, and they're surrounded by pine, and they're on a ridge or they're on a slope, and you're like, oh, well, that's awesome. That's a really beautiful place, but you could not have a house at any moment.
Exactly,
like, especially with pine, right? Like, it's
exactly it burns like hell. And the thing is, like, and the more you delay in those ecosystems that are fire dependent, the more you delay the occurrence of a fire, usually the bigger fire it will be, the harder it will be to fight, if you can fight it even.
Well, the more fuel there is, the more
exactly. So it's a big question, and it's something that's very active part of fire science right now. You know, like trying to integrate more of those social aspects and how to communicate about the problem with people. Yeah. But it's hard.
For sure. No, absolutely. Yeah. So that's good. So we know we're going to get more fires. It sounds like that's the general trend, more fires, and that's an issue, right?
Yes, exactly.
So we came here to talk about fire and water and the effect of increased fire activity on our drinking water and stuff like that. So let's start real quick. Just explain. People might not understand, like, what a watershed is, right? So let's just go through that quick.
Yeah. So watershed is just like very simply, that's an area, geographic area or topographic area, like you would be able to draw it on a map, and following a ridge line. So basically that's like the most simple version of when we learn what is a watershed is like kind of a circle following a ridge line. And in this area, all the precipitation falling, I mean, most of the precipitation falling, whether liquid or like solid precipitation, will end up at the same outlet, right? So like, or will go out of the area through only one stream.
So it's basically a collection. It's where all the water gets funneled into one stream.
That's like a sink, and like collecting all this water and like going only out through only one outlet. And I mean, most of it, because then there are also like groundwater movements that are like way different, and that could also like create some connections between different watersheds. But like, let's say for to keep it very simple, that's just like this idea of a sink. And but there are also several scales, you know, like we tend to always use this word watershed, but actually it's a collection of different scales, from what we call a catchment, that is would be a few hectares big, to what we call a drainage basin. And usually drainage basin, we will use this word to large globally significant rivers like the Mississippi, the Mackenzie, things like that. You know, and that's what we will call drainage basin. So you have several type of scales, and like usually a watershed would be from a few hundred hectares to a few like 10,000 hectares. You know, things like that. So and depending on where you are in the world.
Depending on the
It's
scale.
not exactly the same type
Yeah.
of limits. Either,
Well, the scale
so-
keeps going, right? Like
Yeah,
you say, What's
exactly.
the watershed? There's technically a watershed for a little stream, and then that turns
Yeah.
into the watershed for the North Saskatchewan River, and then that turns and whatever, right? It keeps getting bigger. So
But what I think what is important in the notion of watershed and the way we use it a whole lot when it comes to risk management in hydrology or even like wildfires is like it's basically the this geographic area that serves water to one or several communities downstream.
right.
So it's like it makes some sense in people's minds, like like basically where my water comes from.
Exactly.
So that just as simple as that.
Simple as that. Yeah, exactly. Perfect. So maybe we start getting into how the forest relates to like water filtration and how so just trying to set up that whole system.
So in forested watersheds, and I want to be like very clear on that, is like I would say naturally forested watersheds, just like within which there is already some sort of natural functioning within which water and forest are highly dependent,
Yep.
So and I we can come back on that later, but like so let's say here in Canada or in Alberta, we know that most of our water comes from surface water comes from the Rocky Mountains,
right.
so that are it's the water coming from here is dependent on the amount of snow we have in the mountains. And so big part of the water we have just comes from snow precipitation, so solid precipitation just falling down on forests we have in the Rocky Mountains or in the foothills.
Yeah.
And so
the creek has to start somewhere, right?
Exactly.
Yeah.
So in this forest, like it is like acts there is some sort like a double effect. So there is a the first effect is like some sort of like sponge effect. So you have like those fairly like old forests, or at least like evaluate forests that you have soil. Soil is a critical aspect when it comes to forest hydrology and the water that is served downstream.
Soil being just explain the difference between soil and dirt. Like people
the thing is like soil, and like especially in forest soil, you would have like several layers, like litter, like which is like basically leaves,
sticks.
like organic sticks, even like dead animals, whatever like comes on the ground. And then like this litter starts to be decomposed, and you have like some humus, and then you have like, and the deeper you go, the more I would say elaborate soil you have, like more complex soil you have.
So it's mostly organic though, right? Like it's
what is important for us is like the organic part and the amount of organic matter in that, and how like what is how well the soil is able to basically absorb the water and make it percolate to aquifers, or just like to keep it in subsurface, and like just then the water is redistributed downstream, and like keeps rivers flowing basically. So this soil has this effect of like this kind of sponge effect, like can absorb the water, store it, and like redistribute it along the year. And it also acts as some sort of like a natural filter, it will just keep a whole lot of pollutants, like, and that's when it comes to water treatment, we actually kind of mimic that, like the whole filtering system mimics this idea of the soil like just holding a whole lot of the the pollutants. So that's really this idea of forest, and especially forest soils have this capacity to absorb the water. The vegetation that is growing also absorb the water, right? So you have this whole complex that is really really important in terms of water water storage and water redistribution along the year. So that's the first effect. You also have this second effect that is more this effect of a shield. Okay. So when you have, especially when you have thunderstorms, like big rainstorms, you have the impact of the rain, of the raindrops on the ground can be quite strong. So when you have a forest, we have a phenomenon that we call interception, and it's basically the forest and the natural vegetation blocking, like just intercepting the water, and so
before
avoiding
it hits the ground.
Exactly. So avoiding this kind of like effect of like a hammer, just the rain hammering the soil.
So the rain will drip down the vegetation softly rather than just like hitting the soil and exploding.
Exactly. And so that is very important as well, and also because it this shield effect also allows as you just said, like to slow down the water.
Right.
But this water eventually will still arrive to the ground. But because it arrives like at a slower motion, it just allows the soil to absorb it as well. Like the soil has a certain capacity to absorb water at a certain speed.
Right.
If too much water comes at the same time, the soil won't be able to absorb it and it will run off.
Right.
So and here we have basically all the elements of like what is important in forest hydrology and how it controls the water we can have downstream. Once again, here in boreal or temperate ecosystems or watersheds. But when you have a fire, then suddenly those two effects can
they're gone.
They may disappear. Yeah, exactly. You know, so
there's nothing to absorb it, and there's nothing to get in the way of the water. So the water is just smashing the ground, and it's flying across.
Exactly.
As well as I imagine. Will char, like once things are charred up and burnt, they become hydrophobic, right?
Yeah,
so
exactly.
They
so
repel
you have
water.
Yeah, and it's a very big field right now in terms of what we call post-fire hydrology and hydrogeomorphology. It's like what is the effect of first the ash layer? So after a fire, you have this ash layer, and depending on the type of vegetation, depending on the type of moisture conditions after the fire, this ash layer may respond very differently to the rain. And then you have, as you said, like this issue of hydrophobic layers. So this layer that might be already present, that may be enforced or may appear after a fire, just block this this percolation, like the penetration of water in the ground. So once you have this ash layer that has been like just entrained downstream by the surface runoff,
so washed away.
Yeah, you have like it's the water repellent layer, and so nothing penetrates either. So it keeps flowing and flowing.
Yeah. So all that water that would have been. So how much water do you think would be relative to, say, you had like a nice like aspen spruce mixedwood forest, right? 70 or 80 years old. So you got like lots of vegetation. There's some good humus there. There's moss and stuff. How much of that is being absorbed, and how much is going on runoff for like a natural stand? Just roughly, just to give an idea.
That's a very good question.
Like it depends on the moisture of the soil and all kinds of things,
plus
right?
the interception, like, you know, in temperate deciduous forest, like on average, like it's like 30% of the rain is intercepted, for instance, and then will be evaporated, like partly evaporated. So well, that would be a very complicated question.
Yeah, I imagine it
actually, because
I'm just trying to give a feel for like the difference between something that's burnt and something that's unburnt, right?
Well, you know, it just I guess what we could. That's
Maybe we should have sent you that question.
Yeah, well, the thing is, like, you know, we like on some studies that have been done, you know, we and depending at the scale as well, you know, if you work at the scale of a hill slope or a water basin, you won't have the same response. But some people like have noticed increases in runoff, in water coming from burnt areas, by more than, you know, that could be from dozens of percents to, like, we have a few cases at the hill slope scale, if I remember correctly, that it's more like 1,000% increase.
1,000% increase in runoff. So there's a lot.
So that could be a lot, but once again, you know, that's hill slope scale. And then in hydrology, and when it comes to hydrology, erosion, and things like that, we know that there is a huge scale effect. So what you can see at a hill slope scale, and like where usually in the literature, that's where you will see like most of the increases in erosion, so sediment production and water yield. And it's like, you see like incredibly like plus 300% and things like that. Yeah. But then when you scale up all those things, then you see that you will still have an effect. But then, you know, it goes down to,
so it's a lot anyway,
10%, 15%. So it just decreases then.
Right. Gotcha. Okay.
But because and it makes me think of a very important, I'm talking about the scale, and that's what it's a very, very important factor here. When we are trying to think about the impact of a wildfire on water resources, it really depends where the fire will happen in your watershed, how far from a water treatment plant, and how much water comes down is available in the overall watershed. Because in water treatment, like I think water treatment engineers tend to say that dilution is the solution to pollution, and that's I mean that's a kind of a rule of thumb, but that makes sense like in terms of like geographically speaking, because it's basic kind of I would say chemistry, like
so essentially just that. Like dilution, by dilution you mean that the whatever pollutants or particles that end up in the water will settle to the base and won't end up downstream. So basically,
what I mean is like, if you want to make the test by yourself, like if like for the same amount of I don't know, let's say whatever nutrient or oxygen. Let's talk about oxygen. Just like the amount of the concentration of oxygen. In like a small glass of water or in a lake, like you can have the same total amount of oxygen, but in one you will have like the smaller is the hydrological unit, like the higher is the concentration. So that's this idea of dilution, is if you have a fire in your watershed, but that happens like hundreds of kilometers upstream, like for the time for like you will have more runoff coming out of this burn area, and you might have like polluted water, like turbid, with some nutrients and
it's going to be diluted by the time it gets
exactly. So you may not even see any signal, or not even a dangerous, I would say, signal in terms of water treatability.
But if it happened right next to the water treatment facility, then it's a bigger issue.
And Fort McMurray, once again, is a very good example of that. It's just like it happened right in the around the city, around the town.
Basically.
So it's just like this idea of dilution. It doesn't apply here because the water, fire polluted water just comes out of the like just a few hundred meters at the water treatment plant. And I've been up there, and like you see all around, it's burnt. So it's polluted water can come right away. Without any dilution effect. So it's but it's a special case, I would say, But we have more and more examples of, I call that like fire polluted water. Just if especially in this idea of if we have more fire and bigger fires, we might see this kind of issues more and more often. So.
Yeah, so definitely with more fire, you're getting like more ash, you're getting more runoff. Therefore, you're getting probably more erosion. You're getting way more sediment in the water.
Yes, and what is important is what we call sediment-associated pollutants.
Okay.
And a lot of nutrients or heavy metals, for instance, like basically they are attached to sediments. Like they like being attached to sediments, basically. So the more sediments you have, because after a fire you usually have more runoff and with higher velocity, so higher erosion as well. So more sediments, and because you have more sediments, you will have more pollutants as well. But once again, it depends of the soil type. It depends of a whole lot of things.
But you can safely assume that if there's significantly more sediment, there'll be significantly more pollutants.
Well, usually that would be the trend we would see.
Gotcha.
Just like that's definitely the type of thing we could expect.
Right. Okay. Interesting. So, as far as these are concerned, like the risk of increased fire activity on water. So you're gonna get way more of it. You're gonna get way more water, way more sediment, way more pollutants, and all that. So how much, like what is the problem? Just is it more of a financial thing? So like it's gonna cost way more to get that water drinkable, or is it, or what's the real issue with
Well, I think like just like to finish on the previous statement, just to be clear on the fact that sometimes a big driver of post-fire water pollution is the occurrence of a rainstorm, because like you need this water to drain these old sediments and things like that. So we have cases where after a fire we basically don't really have a response of the watershed and the water yield and things like that, because we just basically don't really have rain. So like we have cases where a few years after, we are in drier conditions than usual.
So you don't see that sediment.
So you don't even see any signal. But let's say like let's maybe talk about like kind of worst case scenario kind of thing. But so what you would have like all this water coming in, and most in the world, most, and including in Canada, most of the water is used by withdrawn and consumed by people or industries is surface water. So. But this water is not, maybe in developing countries, or like, but let's say in Canada, like it's not served directly. Like here in Edmonton, we draw the water out of the Saskatchewan River, but it's obviously treated. You know, it doesn't come to your tap like directly.
Of course, yeah.
So, and what would be the problem in case of you know, like fire related pollution would be the treatability of the water. Like we have no documented case of water that has been served, like people opening their tap and have water that is polluted and
that's
not proper for consumption, and has been like and this problem has been related to fire. We don't have
that's not happening.
This case. No. Because like that's the job of, you know, water treatment engineers and water treatment plants, is just like to serve proper water. And if they are not sure of the quality of their water, they will ask for a boiled water advisory and things like that. And once again, that happened after Fort McMurray, you know, just because if you're not sure, you know, better go with that, or, you know, they will distribute bottled waters and so. But yeah, like the biggest problem will be in terms of treatability, so the capacity to make this water proper for consumption.
Of course.
And
the forests act as that filter, so it
like
makes it
natural.
easier
Exactly. So even if like I would say ecologically like healthy watershed, you would still have to treat the water.
Of course.
But like in France, for instance, we have done a whole lot of studies about like the quality of water coming from a forested watershed and coming from agricultural watershed.
Oh, really? Okay.
And we see that the like I'm not sure of the figure anymore, but like the cost is like of treatment down the road. It's like it's not even comparable.
Oh,
like,
really?
You know, it's like
so forests are an excellent
like,
filter.
Oh yeah, like it's like 1 to 2 orders of magnitude in terms of the money
really?
You have to put in to treat the water.
Yeah.
So we really have like the importance of forests and to provide this clean water, and like it's very, very important. And so if you have like fire polluted water coming in, you will still be able, like as I said, you know, like water treatment plants kind of mimic this filtering capacity, but
it's expensive. Takes a lot of resources,
and then you will have to probably change the filters at some point, or you will have to use more like chemicals to treat this water. And it may take more time, more money, and so that's kind of we're more concerned about that. You know, not necessarily like there is obviously a threat that you have polluted water going down in the distribution system. But what right now in a country like in Canada, where we have like in many places, fortunately, like good water treatment capacities, like we are mostly concerned by the money it costs to then distribute the proper amount of water. Yeah. So, but you know, even in Canada was like I would say on the world stage, which is like kind of a model in terms of water availability and management. It's like we realize that even at the scale of the country, we have issues, and in northern communities, we were talking about wildfires and climate change higher north in the future, and we know that there are still several northern communities that have been under a boiled water advisory for decades now, and that don't have the proper water treatment capacities. So, and let's think like if those places up north have a fire in their watershed, and it's like what will happen, you know?
What are they going to do?
Maybe here in Edmonton or Banff or Jasper, and it's like, or Calgary will be like, that's fine. Fort McMurray even, you know, Fort McMurray just...
They've got the infrastructure to deal with it.
Exactly.
And some places don't.
What if that happens in some places where, and including in Canada, where this capacity doesn't exist? Yeah. So, but those assessments haven't been done so far. So it's kind of the questions, so I'm starting my postdoc. I'm just done my PhD on the topic, and I'm starting my postdoc, but more at the Canadian scale. Yeah. And it's part of my work is to actually, kind of assess this risk and work on what we call ecosystem services. And so we talked about this filtration capacity of the forest, and how fire can impair this filtration capacity. And I'm gonna work on that. So evaluating the amount of ecosystem, like water ecosystem services, so those water services provided by the forest,
Yeah.
and how wildfires can actually impact those at the scale of the country. And hopefully down the road, I'll be able to say, yeah, well, just like we might have to make a move on northern communities, or maybe in Eastern Canada or Western Canada.
Right.
So
it helps you focus on those areas that are high risk.
Yeah, exactly. But we need to know where is this risk,
Right.
and that's what that was one of the point of this paper that I published in August. That was a global scale study of where are wildfires and where is water, and where are people or ecosystems that are dependent on this water, and that might be at risk in case of a fire. And I wanted to do that on a global scale because right now most of the studies are limited, first of all, to a few number of countries. Like basically post-fire hydrology has been studied for 40, 50 years, which is fairly decent, but it has been limited. It's been limited for into the US, Australia, South Africa a bit, Spain, Portugal, Canada is really starting on that, and a few other countries here and there. But so it's a limited number of countries, and it also means by extension a few number of ecosystems. Just we are really far of having something that is representative of all ecosystem across the world. We have started to have just 2 recent papers in Brazil, and it's the first time I've seen them.
Right.
It's been published like this year.
Yeah.
And that's the kind of the first papers coming from this part of the world talking about fire impacting water. So we still have a whole lot of things to do. A lot of places we don't know what's going on.
It's tough. World's a big place.
Yeah, exactly. And and also because what was the point with this study is kind of raising awareness. So first, like at our own scale here in Canada, in Edmonton, but also in places where the water treatment capacity doesn't exist, or maybe the water resources are more scarce, and in case of a fire, those water resources are more at risk, I would say. So yeah, that's the overall idea, the importance of forests as of natural areas as providers of good quality water. And this idea of, we have to try to extend our knowledge to other parts of the world. Yeah,
for sure. I remember I was at that talk with Monica, and her last name eludes me right
Emelko.
now.
Monica Emelko.
And she was at the Phil's lecture there, and she said a number, something about the relationship between a specific amount of boreal forest in relation to how much that equals to a filtration system, like anthropogenic, like something we made, right? So do you remember what that
I think like this graph she showed is like an based on empirical relationships between the amount of the water quality and the price. That was the price of producing drinking water, right, as a function of the forested area, the watershed. Yeah. And so what we see on that is the more forest you have, usually your price
drastically decreases.
Yeah, exactly. Yeah. So and we have this type of we have a fairly good knowledge of that. It's we have, once again, variability in the way it works, but there is a fairly worldwide agreement on the fact that forested areas are good for water protection and water resource protection. Yeah. But it's part of I would say a much bigger debate that is actually, I think, getting to an end. But it's forest provides more water or decrease the amount of water, and it's a discussion. I know in Southern Africa, they had big afforestation projects and
afforestation.
Yeah, afforestation.
Yeah, so reforesting.
Yeah, exactly. Not necessarily reforesting, just even sometimes creating forests from scratch.
Right.
And this because they thought, we're gonna have more water because forests creates its kind of own microclimate with more rain, and so we'll have more water.
Holds
yield.
On to the humidity, probably.
Yeah,
better,
exactly.
Right? Yeah.
And but then they realized that the species they used was sucking way more water than was. So
would they use eucalyptus or something?
They use some sort of some sort of conifer that is common in Southern Africa, but yeah, that is highly water demanding.
Just sucking it all up.
Yeah, and eucalyptus is a very good example as well. In Australia, I really like this example from the 80s where they saw that after a fire in eucalyptus, like the young eucalyptus regrowing was sucking way more water. And so before, for I would say the stream to go back to the previous natural flow, it took up to 150 years.
Really?
Yeah. So because you have this vegetation that sucks so much water.
So you think that's just because the density is way more? Like, so instead of having one like 100-year-old tree in a space of X, say whatever it is, 10 by 10, you've got 100 small trees that are trying to compete for one another. So
that can be a part of it, and like density, like the age, age of the vegetation, and also just the biology of this very specific species.
Right.
So and that's why, once again, we have it's so hard to to draw, like, to generalize, and that's why I'm always trying to be very careful with that, because
I'm horrible for that.
Like the kind of trends we've seen so far, and like, we first of all have quite some variability, but also it's only based on a fairly low number of not studies, but a fairly low number of ecosystems. So
so you don't got a lot of samples.
So it would take way more like knowledge from all around the world to know what's going on, like, to be sure we can draw, and we would probably not even be able to draw like general trends. Like, we would probably have to subset them in a few like regional trends.
Everything's so different that there's a lot not much
and that's one of my colleagues down in the US, like Denis Alema. He published earlier this year a paper showing, like, at the scale of the US, that we can actually divide the US, I don't remember, in 3 or 4 general regions where fire has a different impact on hydrology. Because
is that related to the watershed, do you think?
It's related in he used the
grand scale watershed.
Exactly, the large scale hydrological units in the US, and it just shows that a fire happening in different what we call hydroclimatic regimes, so like different precipitation and different hydrological functioning, that you don't have the same response in those different regions of the US.
Gotcha.
And that's one of the first regional scale study on that. And that's also something that is important. It's like, most of the studies that have been done in this field have been done at the scale of a hill slope or catchment. And now we start to have more and more studies at larger scale: watershed, water basin, drainage basin.
We need those,
because for the longest time we were like, well, just a fire probably only has a very local impact. But now we are trying to see, like, because we are looking at maybe more types of pollutants, more different ecosystem, different hydroclimatic regimes, we're like, well, maybe that could accumulate like several dozens of kilometers downstream. And there is a researcher last year who ran an Earth system model, so a global scale model, and like trying to mimic the way the Earth works. And in his model, he was able to I would say turn off the global fire activity, and he saw that the amount of water reaching the ocean was decreased by something like 14% when you didn't have fire on the land mass, on the global land mass.
It was decreased.
Decreased. So it's interesting when you start to then think at different scales.
There's a balance that needs to be.
Exactly. So we need fire to a certain extent, and we also see that like if you try to step back and look at fire in the whole natural functioning of Earth. It's necessary. You need fire for the global hydrological cycle. You need fire for the global sediment budget reaching the ocean. So it's
lots of stuff.
And when you start to upscale, it just like then you start to see that the relation between fire and water is actually extremely complex. And I know it's a provocative thought for many people, saying like, we need fire in the landscape to preserve our ecosystem, and maybe down the road to preserve our water resources.
Right.
And I know it's hard for people maybe to process that. But, it's something like
I think we're hashing through it. I think we're getting there.
Well, it's I know it's down in the US, like for pretty much the whole 20th century, it was like Smokey the Bear, like what we call now even the Smokey the Bear syndrome. You know, just like fire is bad. You know, it's like that's the enemy number one, and but then we realized that the fact that we didn't have water, like fire in those ecosystems, and California is a good example of that. It's like we have too many trees.
Yeah.
And there is not enough water for all those trees.
So that would have a role to play in the drought in California.
Probably like to some extent, yeah. Right. You know, it just
along with a million other things, I'm sure that'll add up.
Yeah,
to
exactly.
Perfect storm.
Like the problem with California is like it's a, in my opinion, like largely human-driven drought. You know, it just like they don't have the amount of water. Like they use way too much water comparatively to what they have. So but anyways, it's I think like we've seen in the US like some ecosystem that have like the health of those ecosystems have just started to you know, like to what is the word, like to decrease because we didn't have fire. We had too many trees. I was reading it not that long ago that when the first settlers arrived in the southwestern US, when they started to hunt for beaver pelts.
Yep.
Pelts. I'm
pelts.
Not sure. Pelts. Yeah.
Pelts. Yeah.
And they actually so no beavers anymore. So no dams, and so no all this water that was held by beaver activity up in the watershed was able to then percolate, and then and was just kind of preserving a healthy ecosystem and beavers like some sort of humidity.
Yeah.
When they hunted all those beavers, then they changed the whole hydrologic cycle over there, and like they made the forest way drier than it was and way more fire prone. Yeah. And when you read that,
you lost so much habitat too.
Right? Oh yeah. And when you read that, you're like, oh my God, it's like like just because we killed too much beavers, like we've changed the whole fire system.
It's amazing how it's all interconnected, right?
Like exactly. Yeah. And that's why I think we really tend to and once again, I think the media, whenever those kind of disasters happen, like tend to lower, if not even like hide the human aspect of that.
Yeah.
So
they just catastrophize it, right?
Yeah, exactly. And I think like we what we should try to do is more like talking to people in terms of responsibility, and also trying to maybe educate them more in terms of simple scientific facts, like the fact that like fire is an essential part of many ecosystems in the world, and here in Canada, the boreal forest and is critically fire prone and dependent on fire. And if we want to keep this role of the forest to this filtration role and protection role in our watersheds, we also need to acknowledge the fact that sometimes it will need fire to just regenerate.
Yeah, and sometimes we need to let it burn. Yeah.
In some ecosystems, maybe that would be high frequency but low intensity fire. So like the impact on the forest would be like minimal, but just enough for the forest to stay healthy.
Right.
If you don't do anything and you say, oh no, we don't want fire because like the community
constantly
down
suppress
there,
it. Yeah.
they don't want smoke.
Yeah.
But so we don't have a fire for 100 years instead of having a fire every 10, 15 years.
Well, that's the thing, right? Like even I know in the Rockies here, there was a big uproar over some prescribed burns that went through there, or some of them I think were natural that they just let go through the park because they needed to be done, right? It was their time to go.
Totally.
But people are losing their minds saying that was my favorite trail, and they go, now it's ruined, like you assholes, you ruined it or whatever. It's like, well, no, that's the natural. Just because in your lifetime you've never seen that burn doesn't mean that there's larger things than us individuals. Like people fail to see that relationship exists, right? They think that that's never going to be the same again. You're like well, it will be, considering if the climate stays the same, it'll come back exactly the same. But if it changes, it might be slightly different. But that has nothing to do with it. The fire is a part of the ecosystem.
Yes,
we need it.
Exactly,
so,
exactly. But it's a very complicated story because we also tend like last year in the US there was this publication talking about the more people in the landscape expand the ecological niche of fire. So like there are fires in areas where naturally it wouldn't even happen.
Right.
And so it's
just because of people. Yeah.
Just because of people. So and that's very interesting. And we know that people, by changing the forest cover, there are two things. There are more people in the landscape, and it's a problem when it's in a fire-prone landscape, because like you having your barbecue, you having like whatever type of activities, just can create those ignitions.
Smoking, quadding, whatever. Yeah.
And plus you add on top of that the fact that people like to use landscaping species, like alien species that are highly fire prone, and just like put them right by the wall of the house, the wall of the
towering
house,
cedars.
Yeah, exactly. That's a huge issue, Just
I got a towering cedar next to my house.
Yeah, well, it's something that is that could be quite dangerous.
Yeah.
So that's part of it, but also like I would say like at the we've also seen there was a publication on New Zealand, and I was focusing on New Zealand and how through the millennia the fire regime changed down there.
Yeah.
And it seems to be linked to the arrival of the first Maori tribes.
Oh, okay.
Like 3,500 years ago, something like that.
Okay.
That like New Zealand wasn't that fire prone, but because they started to really target like some very fire conducive moments in the year, they started to light fires, and they created a positive feedback where you have more. So you start to burn some forest, and then you change the kind of the microclimate, like the moisture recycling and things like that. So you make it drier. And so like with the years, you just create more and more drier and drier conditions, and so more fire conducive conditions. So and so the forest just becomes easier to burn.
That's because of people.
But conversely, in Europe, what we call land abandonment, like for millennia, especially like the whole Mediterranean area, we used like probably for the past 10,000 years, like fire. We just like conquered basically the land with fire for agriculture and because we were shepherds as well, so like for the cattle, and so we kept the land open, and also like the cattle going through the landscape would create natural what is the word, like fire protection by creating trails all around the place.
Oh, I see. Okay. And, so they're creating barriers. Yeah, just
exactly.
For the trails. Yeah.
And so, but when, like, between when the rural exodus started, like after the Industrial Revolution, just the vegetation just came back. And but the thing is, like in the Mediterranean region, because we used fire for so long to get this land, but also like to keep it fertile, we would burn every 3, 4, 5 years.
Yeah.
And so even the ecosystem, it's at some point the literature called it a pyroclimax. So the vegetation even adapted to this very regular, high frequency fires. But when we left, this whole fire-prone vegetation started to invade everywhere, and now it's a beautiful landscape.
Right.
And now people are in the middle; they don't.
But it's not natural anymore, right? It's been totally altered. It's amazing the effect humans have on the natural world. Eh? We don't realize it. We think that it's always been like this, but you go back before us and it'd be completely, utterly different. Yeah.
Yeah. Oh, and I used to work in the Pyrenees Mountains in southwestern France, and it's interesting to see over there that they started to have more fire and bigger fires.
Yeah.
But not because of changes in climate, just because of this idea of land abandonment. Like people used to. We used to have families of shepherds going in the landscape, and like they would use fire on a regular basis, but because there were like 15 people like checking that the fire was okay, like trying to pull it out if necessary, and also because you had all this network of trails everywhere, like the fire would never go into the forest. But once that disappears, and you still have people lighting a prairie on fire,
right?
But then they just don't. There is not enough people to like check the fire to pull it out, and you don't have that much cattle in the mountain anymore. So, like the fire can grow in the forest as well, and so it's just an example of having more fire and like larger fires, but not related to climate, related to changes in just the number of ignitions and the way people
So more fire, just basically at the end of the day, more fire creates a positive feedback loop.
Exactly.
Where you get more and more fire, and just continuously more fire, more fire,
and you have like there is the natural context, and there is what we call a social context of fire. So and those two interact, and it's never only one or the other, especially in what we call wildland urban interfaces. So people, houses, human activities in the natural landscape. There are many interactions, so it gets then very, very hard to say, oh, that's climate change because of this fire. It's like, well, it's more complicated than that.
Yeah, it's one factor. Yeah,
exactly.
Well, you mentioned your work and starting to assess the risk, right? Assess the risk. So what are the metrics for assessing the risk? Like, what's the inputs into that?
So the risk, like the general, I would say, equation for the risk is hazard. So you need a natural hazard. You need a hazard. You need values at risk, so exposed to this hazard, and then you have the vulnerability.
By hazard, you just mean the general environmental conditions at that time. What do you mean?
Like I mean like the event itself. So a flood, a fire, or in case here of this of my topic, that would be like fire polluted water. Like
okay.
Yeah,
okay.
That's really like something that is a vector of damage, of potential damage.
Okay.
So and then values at risk, so values that are exposed to this hazard. So those values, so a house, people, whatever good of whatever human infrastructure, things like that. Yeah, they are exposed, and then they have a certain vulnerability. So like it's I don't know if you guys have this in Canada, this history of the three little pigs and the wolf, and the wolf like blowing on the houses, and
for sure.
I've been told the notion of risk at university by starting with that, and it's a very good illustration of the idea of risk. It's just like the house that is made out of straw is totally vulnerable, and the last house that is made out of bricks is like won't move. That's this idea of vulnerability. They are all exposed to the same wind, but they won't react the same. And then you also have this idea of resilience, how people, society, or anything like that is able to answer a disaster.
To bounce back.
Something happened to bounce back. So that's the kind of things, that's the foremost factors that are taken into account.
So where are the major risk areas? Like, where do you think that
well, when it comes to fire and water issues, what we've seen in this global scale analysis is like it can actually happen in many places of the world, like in North America, in Eastern Africa, in Southeast Asia, in Europe as well, in the Great Plains of Eurasian Great Plains, and we just saw that it actually can happen in many areas. But not for the same reasons, and that's what was very interesting for us, is to see that at a global scale, the explanatory factors, like the different controls of the risk, are not the same. And in Eastern Africa, for instance, that would be the capacity, like first of all, like the access to water resources, but also the lack of capacity to answer a potential disaster. It's like for instance, Puerto Rico right now, it's a very good example of that. It's not related to fire, but like the water issues and the lack of capacity. If you compare Houston and Puerto Rico, like it's basically the same hazard,
but different response.
Exactly, totally. So, and that's a very good illustration of this idea of resilience,
which is in the same country too, which is fascinating.
Yes. Oh yeah. And it's so sad to see that, but that's really this idea of but then you can also have, for instance, areas where there is not much fires compared to here in North America. But even if you don't have much fires, you have you have quite a lot of water, but you have so much population, and that would be more the case in Asia. There's so much population relying on those water resources. Then if it's polluted, if you have a fire,
a lot of people
that might be an issue. And also because we don't have the same water treatment capacities here and there.
Right.
So we have to keep that in mind. And it's really the idea of when we did this study, trying to take a step back and say, we tend to be and in science in general, in environmental sciences, to be like fairly limited to a few number of countries. And so we have to take a step back and think like, maybe in Canada we are like, and after Monica's presentation was great, like to talk about the problem in Canada. But I would say it's also very important to consider other places in the world where that might happen. So
because your study was done on a global scale, right?
Yes, exactly. And that's just never been done before, and we were just very curious. And but it's really something to be, I would say, the results of this study, like one has to be very careful when like reading them and like not use them for what it's not meant for.
Right. It's one study. There needs to be more. It needs to be more
and it's based on indexation, what we call indexation modeling. It's just like basically you take a whole lot of factors. Like at a smaller scale, people may be more familiar with what we call multi-criteria decision analysis. It's just basically you take a whole lot of factors that might be involved in what you're studying, and then you weight them. You say, oh, like this factor is the most important, the other one is like the least important, and usually you put a whole lot of like all your stakeholders in one room and you try to kind of vote for, oh yeah, this one is more important and things like that. So you create scenarios, and that's exactly what we did. But yeah, it's to take with a lot of care, because like I wouldn't like anyone like taking that and say, oh, like my watershed for my city is like, oh, based on what Francois did, it's like, oh, I can be at quite a risk of fire, and it's like, as I said at the beginning, there are a whole lot of scale effects.
Oh, big time.
And so like what we could see at a global scale maybe different at a local scale, but it's just not the same purpose in the end. Like what I did is the idea is just to inform I would say like global scale organizations that
people
are
thinking about it, I'm sure.
Yeah,
right?
People thinking about it, and maybe like organizations such as like UNESCO, like people who are involved, or the World Wildlife Fund, who are involved in water management at the global scale and water resources. To just keep that into account whenever they work at then more regional scale and things like that.
It's a basic human right is water.
Exactly.
Right? We need to provide it for everybody, and not everybody can get access to it. If this is an increasing issue, then for sure
it is an increasing issue, and the fact that we tend to have more fire, but we also tend to have like what we call an accelerated hydrological cycle at the global scale. So we have basically we at the global scale we have more or less always the same amount of water. But the way it's first of all spatially distributed, so like where you have like most of the precipitation and water across the world is different, and may change with climate change as well. Like some areas might just receive more precipitation down the road, some other less, and also at what rhythm. So like we have more and more, I would say, hydroclimatic extremes. I mean, more intense, not necessarily more frequent, but more intense. So when you'll have a thunderstorm, it will rain like twice more, three times. So
shit hits the fan, it really hits the fan.
Yeah, exactly. It's and it's this acceleration we also like kind of scared of. And California this year was also a good example. We, like last winter, very wet, whole lot of snow in the mountains. They were like, oh God, just like we won't have end of the drought, out of the fire drought, but then it started to get dry and really dry, and the fire season was absolutely insane. So it's a very good example of what we call this accelerated hydrological cycle, and like hydroclimatic events will get more and more extreme in this way. So that's something we also have to take into account, just like our water resources, the way the rain will be distributed along the year and in space will be quite different, might become quite different, and we will have to take care about that,
Of course.
Because when you have a flood, so let's say at the end of the year, you have the same amount of water in your watershed, but instead of coming as a steady flow all year long, it will just come in two crazy thunderstorm events where it's just flooding. And when and you basically kind of lose this water, right? Just you can't collect this water coming from flood.
And that increases the amount of fire or amount of risk to fire, right? Because people might not understand like the way the drought codes work and the way the fire indices work, right? And that people think that like, oh, we had a big storm last night, we got like 3 inches of rain, like we're good to go. It's like, well, in a week's time, that 3 inches of rain, like it happened so fast, it had no time to penetrate, like you were saying earlier.
Yeah.
So it's not into the soil; it's just the surface. So now, for right now, the surface is wet, but where the dryness was under the soil is still there.
Exactly.
So in order to drastically decrease a fire hazard, you really need to have a prolonged period of precipitation, right?
Exactly. So, because we know, and that's a very, very interesting thing you're saying here, like the way our Canadian fire danger rating system is based on the fire weather index, which is itself based on like sub indices.
Yeah.
And like those different indices take into account the moisture of different soil depth at different soil depth. And we know that the first few centimeters, even like I would say the first 2 centimeters, and usually it's like composed of litter and when you have a precipitation, it will suck up water very fast.
A bunch of leaves and fine fuels, and that they're small enough that they get the humidity. They just suck all up. The humidity, right?
But it also dries out very, very fast. A few hours, and like if you have like wind, it just takes a few hours, and it's ready to burn again.
Yeah.
So you need like it's not like some people would think like, oh yeah, if we have a huge rainstorm, like we're good. It's like, no, like the best protection against fire and in the event of a drought, a prolonged drought, is like to have a steady rain, like nothing
periods.
Exactly.
It doesn't need to be prolonged periods of heavy rain, prolonged periods of just high humidity and constant slow flow.
Exactly. So and that's the best we can imagine. So
just gives the soil and the larger fuels time to absorb that moisture.
Exactly. So it's critical.
Interesting. So I'm guessing you guys didn't come up with any like management conclusions or anything. You're just trying to get the ball rolling on this conversation and get people talking about it so that people can find solutions to this problem. So there's not really any management recommendations.
I think like for the I would say like almost like a decade since we have started. Some scientists have started to work on the impact on on the water supply, the water resource itself, and not only on like local hydrology after a fire. We have started to like think about potential management
solutions.
So down in the US especially, a few labs have created like different models. I've used like several hydrological models to run after a fire, it's like kind of an emergency response.
Right.
And actually, that's what they did. That's what they do in the US. They have the burn area emergency response, and linked to that, like what they do is like they send people on after a fire. They send people on the ground, assess the severity, and like they try to assess how much of the hydrology and like how much erosion will change in the watershed after a fire. So like they use some spatial models, like mathematical equations and stuff like that, to try to predict how much it will change, how much the watershed like functioning will change. So and then based on that, we like those teams try to answer, like try to provide us some response, which is like quite regularly. That would be like using like mulch or straw, trying to cover the burn ground with some organic material to
absorb it,
trying to protect it from like this rain splash and like the erosive strength,
loosening up of the sediment,
just to protect the soil basically. And it works more or less like once like the science is not like decisive on that, but we just like there are tests like that are done. So that's one part, which is like that would be more like like response capacities and watershed restoration as well. In terms of like we say like pre-fire management, that could be we are still also working on that. It's like there are some studies that have been done where we try to assess. We did that in Alberta, as has been done in the US as well. We try to know where is fire, where is water, and like try to imagine like depending on the number of depending on the downstream population that is dependent on this upstream water, like how much population there is and what can be our answers. So we use some fire probability models, and like where we see, oh, okay, what part of the landscape is the most exposed to fire, then what can we do? Maybe like create some buffers in the landscape. So
That's what I was thinking was the buffers, right? Like how much of a buffer on like on a river or a creek or a watershed in general do you think you would need to mitigate the majority of that burn issue?
Well, that's I don't think I can really give a number.
No, but it would help.
But what we know that riparian areas, riparian forests are critical even if we don't talk about fire, we know that they are critical to preserve the quality of water, and like they also comes with very fragile and sometimes even rare ecosystems.
Yeah. So I'll just explain riparian really quick. Just riparian forest, for people that don't know, is just the forest immediately adjacent to a water body.
Yeah.
Yeah. So
and are usually like very wet areas.
It's wetter, it's richer generally. There's good growth, and there's there's a lot of organic matter, so a lot of absorption happening there probably.
Yeah, and we know they really act as like natural filters. We talked about the forest as a natural filter, but like the riparian forest and wet areas are like probably the biggest part of it.
Gotcha. So protecting those riparian areas is a good place to start, probably.
Yeah, exactly. And usually they don't burn easily. Yeah. But because we have maybe like more droughts or more intense droughts, they tend to be more fire prone as well. So that might be something. And there are only a few publications on that. So and I think hopefully in my postdoc I can work a bit on that. Like if we don't have those riparian forests anymore, like how much does it change, or if they burn, how much does it change, like the impact downstream? Yeah. So but they're also like basically like cutting a part of the forest, so we can create like very like targeted spaces in the landscape where we are just going to cut a part of the forest, like create lines in the landscape, so it just like it just block the growth of a fire.
Right.
But it has to be.
They do that a lot in fire management, right?
Exactly.
They have bulldozers that go around
the
boundaries to try and keep it from jumping, or like highways and roads are a good block. But
but it has to be done in the strategic manner, right? So you can do that during a fire event, for sure. But we can also do that, be proactive, and just based on fire probability in the landscape, say, okay, like this area has the highest probability of having a fire. We should try to find a way to just manage the landscape and forest continuity, so the probability decrease. Right. And so I think like it's something that has been done once in the US, and that I hope like we'll be able to do that in Canada fairly soon. We basically created a map of fire probability and a map of, I would say, water availability. Okay. And this researcher just basically crossed the both, like the water availability with the probability of fire, to kind of give a map of water resource exposure to fire activity. Yeah. And that's very informative when you are in a watershed with a lot of people, because then you have a fire, like those areas, we really need to stop the fire, to prevent the fire to go there, because the water coming from there, like the amount of water coming from there is huge, or it's like what most of our supply downstream comes from those areas that really need to be protected in case of a fire. But it's many of those management options so far at the kind of test ideas maybe, and they still need to be. I've seen them written in reports and things like that, but I wouldn't say that there is a clear amount of publications, or
still like figuring it out.
Really showing that it works, it doesn't work, or that it has been implemented in many places.
So we're still sorting it out. We know riparian areas are important, and they need to be protected, and buffers are good, and maybe harvesting certain areas might help in fire suppression or slowing it down. So it's a fascinating topic. Like, it's a topic that I think, as forest professionals, we plan around, right? We manage. But also, it's like I don't think the information out there in relation to fire and water has really been available in the past, and we're just, like you said, we're just kind of getting into that. So so I think that you might start seeing plans change in relation to that maybe a little bit. So
it's a really like developing field. And even like in one of the other motivation for the global scale study we did with my colleagues was like a few reports, one from the World Resource Institute, one from the World Wildlife Fund. But anyways, it's really new that those reports talking about global water resources start to acknowledge fire as a potential source of pollution or water resource impairment. It's really, really new. But that's great because that was something really shocking to me when I started to work on this topic. It's like every year you have like hundreds probably of reports on global water resources and global water governance and things like that. But you pretty much have no mention of fire as an issue, even here in Canada. The World Wildlife Fund, the WWF Canada a few months ago released a report on the vulnerability of our watersheds in Canada to climate change, anthropogenic development, and things like that. Like they checked for something like 16 indicators. I'm not sure anymore. But anyways, like fire doesn't appear, and it's like it's a huge part of our country and the way our national ecosystem and national forest work. And it's like I was shocked to not see it. In this report. So I was like, it's like it has to come. It's coming slowly, but and like I would say, like outside of the traditional like narrow field of post-fire hydrology, that is like mostly like it's a lot of hydrologists, soil scientists, and working at a fairly small scale. So it's starting to grow, and that's really my goal. Trying to advertise on that, and that's
totally. No, it's an important information that needs to get out there, right? And the hopefully more people can like listen to this and hear about what you're doing, and maybe they have some thoughts of their own that they want to expand on research and
totally
kind of go forward, right? So that's kind of the role here, right? So
even testimonies, like so if someone saw something, we talk more and more about crowdsourcing, and I think scientists we need to rely more on that, just obviously, it's hard because it might not come from a very like scientific protocol or anything like that, but like because
data is data.
Data is data, exactly. And if I can get someone in like over there in Kenya, like sending me an email with pictures saying, oh look, we had a fire a few weeks ago, and now we have a rain. Look at the streams down. And it's like I take it, man. I take it. It's testimonies like that are just like the best way for scientists,
really,
to
awesome.
just put more to emphasize our research, and just saying we're not just doing that in our corner because we like that. It's like we really want to, and with what I'm doing, it's like I'm a geographer. I've been trained in risk management, and that's my purpose. That's what I want to do, is like getting data to do some informed risk management. I want to be sure that whenever there is a fire, we have the tools, and it could be communication tools, it could be computer tools, whatever. But we have the tools to answer that, and like in the best conditions, and not necessarily only in the, I would say, Occidental or Western world, but like especially in areas where this response capacity doesn't necessarily exist. And I understand that in many places of the world, this kind of risk doesn't even like make any sense to them. Like I remember my professors telling me, like, risk management is the chance of rich countries, and it's like that's
privilege.
That's a privilege for sure. But just like we should, like, as a scientist, like, and from a rich country, I would say, like, I guess, like, it's my mission, part of it, to work for Canada, but also trying to export my knowledge and work in such a way that places around the world can use that.
The global scale,
totally.
That makes sense. That's awesome. Well, this was an awesome conversation. We've been flying through this. We well over an hour, so
I chat a lot.
You're crushing it. Yeah, it's good. That's perfect. That's the information we need, right? That's what we want. So
well, that's good.
It's been awesome. So I think we got through kind of the whole idea. I think hopefully it makes sense to people and what's going on, and yeah, thanks a lot for coming on. This was really
Well,
good.
you're very welcome. I really enjoyed, having the opportunity to talk about that. And, I would welcome anyone, like want to shoot me an email and say, hey, you know what, just that was good. And I have this idea, or story in my mind that happened up when I was up north 10 years ago. I don't care. It's like, share what you know about that or what, and I'll take it.
What's your email? Just kidding.
So well, I don't know. Actually, if you want to share it on your podcast,
it's up to you, because I can. If people want to talk to Francois, they can email me at yourforestpodcast@gmail.com, and I can reach out to him. And we can get that answer out there.
Sure,
for sure. Perfect. Awesome.
Well,
thanks a lot for listening, everybody.
that you're very welcome. That was great.
Yeah, that was awesome. Thanks for listening, guys.